Hello and welcome to the Certified Ethical Hacker Study Guide. In this video, we will discuss Chapter 2-1, which is an overview of the TCP/IP application and transport layer. Please like, subscribe, and hit the notification bell. Now let's fight our way into the first topic, after this short break. Overview of TCP/IP. For computers to communicate with one another over the internet or across an office, they must speak the same language. This language is referred to as a protocol, and the most widely used is Transmission Control Protocol/Internet Protocol, or TCP/IP. No matter what medium connects workstations on a network, copper wires, fiber optic cables, or a wireless setup, the same protocol must be running on all computers if communication is going to function correctly. You've probably already studied TCP/IP, but a review is helpful to make sure you have a thorough understanding. TCP/IP is more than simply the combination of two protocols, TCP and IP. It's usually referred to as the TCP/IP stack, which contains 4 distinct layers. The network layer is concerned with physically moving bits across a medium, whether the medium is copper wire, fiber optic cables, or wireless, and the internet layer is responsible for routing packets by using IP addresses. The transport layer is concerned with controlling the flow of data, sequencing packets for reassembly, and encapsulating the segment with a TCP or User Datagram Protocol header. The application layer is where applications and protocols such as HTTPS and SSH operate. This module discusses only the application, transport, and internet layers, covered in the following sections, because security testing doesn't usually involve getting down to the network layer's hardware level. However, some computer attacks use physical hardware, such as a keylogger. Now let's leap into the next topic right after this. So, let's talk about the application layer. The application layer protocols are basically the front end to the lower layer protocols in the TCP/IP stack. In other words, this layer is what you can see and touch. Table 2-1 lists some of the main applications and protocols running at this layer. For example, Hypertext Transfer Protocol Secure, or HTTPS, is the primary protocol used to communicate over the web. Then there's File Transfer Protocol, or FTP, which allows different operating systems to transfer files between one another. And of course, Simple Mail Transfer Protocol, or SMTP, is the main protocol for transmitting email messages across the internet. Simple Network Management Protocol, SNMP, primarily used to monitor devices on a network, such as monitoring a router's state remotely. Now let's slam into the next topic right after this. Alright, moving on to the transport layer. The transport layer is where data is encapsulated into segments. A segment can use either TCP or UDP as its method for connecting to and forwarding data to a destination host or node. TCP is a connection-oriented protocol, which means the sender doesn't send any data to the destination node until the destination node actually acknowledges that it's listening to the sender. In other words, a connection is established before any data is sent. For example, if computer A wants to send data to computer B, it sends computer B a SYN packet first. A SYN, which is short for synchronize, packet, is kind of like a query to the receiver, almost like asking, "Hello, computer B, are you there?" Computer B then sends back an acknowledgement called a SYN-ACK packet, which is like replying, "Yes, I'm here, go ahead and send." Finally, computer A sends an ACK, or acknowledgement packet, to computer B in response to the SYN-ACK. This process, called a three-way handshake, involves the following steps. Step 1. Host A sends a TCP packet with the SYN flag set, that is, a SYN packet, to host B. Step 2. After receiving the packet, host B sends host A its own SYN packet with an ACK flag, a SYN-ACK packet set. Step 3. In response to the SYN-ACK packet from host B, host A sends host B a TCP packet with the ACK flag set, an ATK packet. Now let's sprint into the next topic, right after this short break. As a security professional, you should know the critical components of a TCP header: TCP flags, the initial sequence number, and source and destination port numbers. Attackers leverage knowledge of TCP header components. You need to understand these components before learning how they can be abused. Only then can you check whether your network has vulnerabilities in these areas. Remember, to protect a network, you need to know the basic methods of hacking into networks. Each TCP flag occupies one bit of the TCP segment and can be set to 0, off, or 1, on. These are the 6 flags of a TCP segment. SYN flag. The synchronized flag signifies the beginning of a session. ACK flag. The acknowledgement flag acknowledges a connection and is sent by a host after receiving a SYN-ACK packet. PSH flag. The push flag is used to deliver data directly to an application. Data isn't buffered, it's sent immediately. URG flag. This flag is used to signify urgent data. RST flag. The reset flag resets or drops a connection. Fine flag. The finish flag signifies that the connection is finished. The initial sequence number, ISN, is a 32-bit number that tracks packets received by a node and allows reassembling large packets that have been broken up into smaller packets. Steps 1 and 2 of the three-way handshake send an ISN. That is, the ISN from the sending node is sent with the SYN packet, and the ISN from the receiving node is sent back to the sending node with the SYN-ACK packet. An ISN can be quite a large number because 232 allows a range of numbers from 0 to more than 4 billion. Now let's soar into the next topic, but right after this quick break. A TCP packet has two 16-bit fields containing the source and destination port numbers. A port is the logical, not physical component of a TCP connection and can be assigned to a process that requires network connectivity. For example, the HTTPS service uses port 443 by default. Understanding ports is important so that you know how to stop or disable services that aren't being used on your network. The more services you have running on a server, the more ports are open for a potential attack. In other words, securing a house with 1,000 open doorways is more difficult than securing a house with only 10 open doorways. A possible 65,535 TCP and UDP port numbers are available, but the good news is that only 1023 are considered well-known ports. To see the list of well-known ports, visit the Internet Assigned Numbers Authority, IANA, at www.iana.org. The website probably provides more information than you need, but navigating the site gives you practice in searching for information. A successful security professional knows how to be persistent in looking for answers by using a structured methodology. You don't need to memorize the 1023 well-known ports. However, you should memorize the following TCP ports and the services they represent. Much of what you do as a security professional and penetration tester relies heavily on understanding this information. Ports 20 and 21, File Transfer Protocol. FTP has been around as long as the Internet. It was the standard for moving and copying large files and is still used today, although to a lesser extent because of the popularity of HTTP. FTP uses port 20 for data transfer and port 21 for control. FTP requires entering a logon name and password and is more secure than Trivial File Transfer Protocol, TFTP, covered later in this list. Port 22, Secure Shell. Secure Shell, SSH, uses encryption and authentication to create a secure channel over an unsecure network. SSH is used to secure logons, file transfers, and port forwarding. FTP is unsecure, but you can make it secure using an SSH channel. FTP using SSH is known as SFTP. Port 25, Simple Mail Transfer Protocol. Email servers listen on this port. If you attempt to send email to a remote user, your workstation connects to port 25 on a mail server. Port 53, Domain Name System. If a server on your network uses DNS, it's using port 53. Most networks require a DNS server so that users can connect to websites with URLs instead of IP addresses. Port 69, Trivial File Transfer Protocol. Many network engineers use the TFTP service to transfer router and backup router configurations. Port 80, Hypertext Transfer Protocol. Most certification exams have a question about port 80 being used for HTTP. Port 80 is used when you connect to a web server. HTTP is not secure, so most web servers use HTTPS, port 443. Port 143, IMAP. Email clients use this port to retrieve email messages from a mail server over a TCP IP connection. Port 443, Secure Hypertext Transfer Protocol. Port 443, like port 80, is used when you connect to a web server. However, 443 typically is reserved for secure connections. If you find this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. Thanks for watching. See you on the next one.